Hello friends, welcome to Susan and John MathTube. In this video, we are going to continue with equations solvable for x and y or x or y, and also we will discuss a little bit about Clairauts. Okay, so point number 1, if you are solving for x, we have to write the given equation as x in terms of y and p. And then what will you do? You will differentiate with respect to y. And then what will you do? You will remember the fact you have to replace dy by dx with p and dx by dy with 1 by p. And then I told you it's freestyle. You take everything to the left side. Maybe the equation will be homogeneous or it can be linear, or you will be able to factorize and it might become variable separable. Okay, now one more thing I told you in the last video, Clairaut's equation. Remember, Clairaut's equation you can identify very easily. It will be and it must be in the form y is equal to p into x plus some function in p. Something will be written in terms of p. Whenever you get Clairaut's equation, you should remember it is already solved for y. Can you see? Y is written in terms of x and p. So you differentiate with respect to x, and of course you will get two factors, and one factor which contains dp by dx will give you general solution and the other one will give you singular solution. And if your equation is Clairaut's equation, you have to and you must find both according to your syllabus. Okay, so let's start with one question. So write solve y minus x into p is equal to a into y square plus p. So we have a differential equation. I can see that y comes 2 times and x comes only 1 time. So that gives me an idea. I can write x in terms of y. So I'm going to write x into p. I'll take it to the other side. So that will be y minus a into y square plus p, and that gives me x into p is equal to y minus, open the bracket, a y square minus a into p. So x equal to, I'll divide throughout by p. So we get y by p minus a y square by p minus a p by p. Because I told you solving for x means you're going to write x completely in terms of p and y. Minus a y squared by p minus a. Now don't forget to call this step as equation number 1. We may need this at the last. Okay. So what should we do next? I told you in the beginning we have a very systematic it goes step by step. So I have written x in terms of y and p. So this is solvable for x. Now I have to differentiate this with respect to y. So I'll write differentiating with respect to y. So dx by dy. Now we have to apply u by v rule. What should we do? We have to apply u by v rule. So denominator, what is the derivative of y with respect to y? Yeah, 1 minus y into dp by dy, the whole divided by p square. I hope you remember quotient rule. Minus a is a constant, and again we have to apply u by v rule. So that will be denominator into 2y, because you are differentiating y squared with respect to y, minus numerator into dp by dy, the whole divided by p square, minus, what's the derivative of constant? 0. So differentiation is done. Now what should we do next? Yeah, replace dy by dx with p and dx by dy with 1 by p. So I get 1 by p is equal to, do you remember we can write a minus b by c as a by c minus b by c. So I'm going to use that. This will become p by p squared minus here we will get y by p squared into dp by dy minus, now look at this, I'm going to divide as well as I'm going to take this a inside. So minus a, that p will get cancelled. So you'll get 2y by p minus minus will be plus a y square by p square into dp by dy is equal to, oh no, that's it. Now what should we do? Now it's freestyle. Only one thing I can tell you, you can take all the things to the left or all the things to the right and try to simplify. Maybe it will be a linear equation, or it can be a homogeneous equation, or you will be able to factorize and it will become variable. It might become variable separable. So anyway, the good news is this is going to get cancelled. I don't know whether it's good news or bad news, because when we simplify we will know. So yeah, I think I should take this and this common. So I can see that dp by dy and a y square by p square. Can you see I'm trying to combine this and this? So that will be minus y by p square, and I'll take this to the other side because now the other side became 0. So we get 2ay by p. So dp by dy, so the LCM is p square, a y square minus y by p square equal to 2 a y by p. Oh, I should have taken y also common, and I'll do it in the next step. So dp by dy. That's good news. Here we didn't even have to factorize. It is already variable separable. I can see it's variable separable because, can you see, ay minus 1 by p is equal to 2ay. So this y also gets cancelled. Now I'll show you in 1 second how it is variable separable. Look, this is going to become dp by p. I'm leaving this dp and p over here, and the remaining things I'll take it to the other side. So 2a, it is already here, into 1 by ay minus 1 dy. Okay, that's it. Now it's variable separable, so time to integrate. So if you want, you can put integral symbol here. So I should write L and P, but in most of your books they're simply writing log P under the assumption the base is E or a natural logarithm. So let's follow them. Log P is equal to 2A. For those students who do not know the formula, let me put it here. Integration of 1 by x is log x. I mean natural logarithm of x. So integration of 1 by ax plus b will be log ax plus b the whole divided by a. So with that information we can integrate this. This is going to be log ay minus 1 the whole divided by a, plus, since every term has logarithm, I'm going to put log c, and this will get cancelled. This 2 will go above here. So log p is equal to log ay minus 1 whole squared plus log c. Can you tell me what is log a plus log b? So we get log p equal to log a multiplied by b. So p is equal to c into ay minus 1 the whole square. Okay. Now I hope you remember what I told you in the last video. After this you have two options. Option number 1, from here you can write y in terms of c and p, or rather you can find the value of y and put it in equation number 1. Equation number 1 means the one in which you wrote x in terms of p and y. You can plug in the y value and you will be able to write y and x or x and y in terms of p. If you are trying to find such a solution, that will be called the parametric solution. If you are writing x and y in terms of p, what do you call that solution? It is called parametric solution. Now the second option is destroying p, eliminating p. We do not use the word destroy normally. The mathematical term is eliminating p from the given equation. So I think elimination will be easy here. So what I do is I will go to the given equation, y minus xp. So y minus x into p is equal to a into y square plus p. A into y square plus p. Now if you are writing the solution like this, it is called implicit solution. Now I'm not going to waste your time simplifying this. You can simplify. In examination you have to simplify. Anyway, I'm leaving it right here. So I have given you two options. If you want, you can write y and x in terms of p, but you have to mention that this is the parametric solution of the equation. Option number 2, you can destroy p from the given equation and that will be called implicit solution. Anyway, let's do one more problem so that the method becomes like extra clear. So please write the question. Solve the differential equation y is equal to y into p square plus 2p into x. Look at this. I can see that y comes 2 times and x comes only once. So I know that solving for x will be easier. So I'm going to write x in terms of y. Now I have to divide throughout by 2 into p. So that will be y by 2p minus yp square by 2p. Anyway, that's it. So we get 1 by 2 y by p. Now I'm making things in such a way that differentiation will be easy. Don't forget to call it equation number 1. We may need this step, because if you're planning to write the solution in parametric form, we will use this. Okay, now it's going step by step. So I have solved x. I have solved for x. Solving for x means writing x in terms of y and p. Now what should we do? If you solve for x, differentiate with respect to y. So we get dx by dy is equal to 1 by 2 into, we have to apply u by v rule. Denominator, derivative of numerator minus numerator, derivative of denominator, the whole divided by p squared, minus 1 by 2 into, you can apply product rule. First function, derivative of second, plus second function into derivative of first. Now what should we do next? Till now we have a system, we have some steps. So the next step is you replace dy by dx with p and dx by dy with 1 by p. And it's about simplification, all about simplification. So I'm going to take this 1 by 2 inside and divide throughout by p, because a minus b by c can be written as a by c minus b by c. So 1 by 2 goes inside, p by p square, minus 1 by 2 goes inside, y by p square dp by dy, minus, I'm going to take this 1 by 2 inside, dp by dy minus 1 by 2 into p. So here we have 1 by p. So I'm going to take everything to the left. 1 by p minus 1 by 2 into 1 by p, then plus 1 by 2 times what you call y by p square dp by dy plus 1 by 2 y dp by dy plus 1 by 2 into p is equal to 0. You have to be extra careful if some plus or minus goes wrong, that's it. Anyway, here you can simplify. Can you see 1 by p is common and 1 minus 1 by 2 will give you 1 by 2. So we get 1 by 2 into 1 by p, right? Plus 1 by 2 y by p square dp by dy plus 1 by 2 y dp by dy plus 1 by 2 into p. Now I told you simplification is done. Now this is freestyle. This equation might be linear, it can be homogeneous, or you might be able to factorize. But I can see that we can factorize here because I can see, okay, I'm going to take 1 by 2 p square. So I'll be left with p plus 1 by 2 p square goes outside, y dp by dy plus 1 by 2 is common, y dp by dy plus p. That's it. Now we have the common factor. So p plus y dp by dy. In most of the problems that I have seen in your question papers, it's like what you call, whenever you are able to factorize, the equation gets reduced into what you call variable separable form. But there are more options, so always be careful. It might become homogeneous or linear. Yeah. So anyway, can you see the most important thing I told you in the last video? Are you able to see two factors? Okay. So the factor which contains dp by dx, dp by dy, that will give you general solution. And the factor which do not contain dp by dy, etc., that will give you singular solution. And singular solution will be considered only for Clairaut's equation in your syllabus. How do you identify Clairaut's? Very simple. It should be and it will be in the form y is equal to p into x plus some function in p. Okay, anyway, this is not Clairaut's. You can check the equation. So I'll go for the general solution, p plus y dp by dy equal to 0. And as expected, this is variable separable. P is equal to minus y dp by dy. So I'll get dy by y is equal to minus dp by p. And integrating, we will get log y equal to minus log p plus log c. And what is log a minus log b? So we get log y equal to log c by p, or we end up with y is equal to c by p. Now once more, I am leaving the last part for you. It's your choice. If you want, you can put this y value in equation number 1 and you'll get the x value. If you plug it into equation 1, I'll show you. Can you see equation 1? Yeah. You can replace this y with the value that we found just now, so that you end up with x and y in terms of p. That is called parametric solution. If you want, you can leave it as such. Another method is you take this equation and find p. P is equal to c by y. And plug it into the given equation. Plug it into the given equation. You can plug p is equal to how much? C by y. And that will be called the implicit equation. So I'm leaving that part to you. And one more very important thing, just now in the last two, like what you call, in the last video and this video, I gave you an instruction on how to deal with equations solvable for x and y. We'll do one more video in which we'll discuss Clairaut's equation, but the most important point is work out a lot of problems based on this. This is a little bit tough compared to the other part of first order differential equation, so that you become, like what you call, strong for the exam. You can take the past paper questions and work out a lot of questions based on this. Anyway, I'll be back with another video very soon. So till then, my friends, bye.